The next part of 8.4 is looking at what happens when first you have to either multiply or divide, and then you need to simplify the rational expressions. So it's going to use a lot of what we just did in the last video, but now kind of have that extra first step of multiplying or dividing. So I'm going to do the 3 multiplying across the top, and then I'm going to show you the slight difference with dividing. So when you're multiplying, you have a couple options. You can either multiply straight across and then reduce it, or you can do something called cross simplifying. And I'm actually going to do that a lot because students often find that to be a little bit easier. What I mean by cross simplifying is if you have everything written as a factor, so all of these on the screen, we don't have any adding, we don't have any subtracting, so we don't have to worry about any factoring. I can simplify any numerator with any denominator. So what I mean by that, in this first one, you'll notice you have a 3 in the numerator of the first fraction and you have a 3 in the denominator of the second fraction. That is allowed to cancel. They don't have to be right on top of each other to do that as long as they are factors. Now I can do the same thing with the x's. I have 3 x's on the top. I only have 1 x on the bottom. So I'm going to cancel this 1 x with one of these, so that'll drop down to a 2. Your last step is just to write what didn't cancel, what's left. So you have an x to the second on the top, and you have a 2 all by itself on the bottom. And that is your answer. So that's one option. The other option is you could just multiply straight across first. So if you multiply straight across, you would have 3x cubed over 6x, and then you could simplify it by reducing the number, the coefficients, and reducing the variable. So it's your choice. The next one, first thing I notice is my x cubed is on the top and on the bottom, so that factor will cancel on the top and bottom. When I look at the numbers, nothing cancels. 5 over 6 doesn't cancel, 5 over 4 doesn't cancel, 1 over 4, 1 over 6. So I'm just going to multiply what's left straight across. I have a 5 times 1 on top and a 6 times 4 on the bottom. And if you're unsure, you think maybe you forgot to simplify, you can also use your calculator, type in 5 over 24, use the fraction button, and it will show you that it is already reduced. Next one has a lot of simplifying that can happen. I kind of wanted to show you different levels here. So you have a 3 on the top and a 9 on the bottom. That will reduce to 1/3. You also have a 2 on the top and a 4 on the bottom. That will reduce to 1/2. And then finally, you have an x on the bottom and an x to the second on the top. 1x will cancel with 1x, so you'll have just an x left on the top. So when you look at what's left, you have only an x on top, a 1 times an x, and then you have 2 times 3 on the bottom, and that's your answer. So if you're multiplying, you can simplify as much in the beginning. You can wait till the end to simplify, as long as in the end you write down your simplified answer. If you are dividing, this goes back to kind of a basic algebra 1, maybe even pre-algebra idea. Dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to write that down. That should sound very, very familiar. Reciprocal. I'm not going to write the whole word. So what that means is your first fraction doesn't change. It stays as 7 over 6x cubed. Anything after the division sign is going to be written as times the reciprocal, meaning the flipped version of that fraction. Once you do that, it's exactly the same as the problems up above. You want to see what will simplify. The 9 and the 6 will reduce to 3 over 2 because both of them are divisible by 3. Numerically, I don't see anything else. With my variables, I have x to the second here. I have x to the third here. So 2 of the x's are going to cancel on the bottom and top, leaving you with just 1. So what I have left is I have a 7 times a 3 on top, so 21 on top. I have a 2 times 2, and I do still have an x on the bottom, and that will not simplify because 21 over 4 is completely reduced. Here's another way it can be written, and Delta Math's going to do it in both ways. It's going to use the division, but it's also going to write it like this. This is called a complex fraction. When you have fractions over fractions, they're kind of messy looking. They're really easy to fix, though. You're going to take your top fraction, which is the 3 over 2x, and then you're going to multiply by the reciprocal of this bottom fraction. So instead of 5x over 6, you're going to multiply by 6 over 5x. So that's how you take a complex fraction and turn it into the multiplication of two simpler fractions. Looking at simplifying, there's not a lot. 6 over 2 will reduce to 3 over 1. And I think that's about it. Going across the top, 3 times 3 is 9. Going across the bottom, I have a 5. X times x is x squared. So when you write it in Delta Math, just make sure that you have the entire 5x squared in the bottom. Sometimes the way you enter it can give you a little bit of an issue. So that's how you divide if it's in a complex fraction look. You write the original, the first fraction, and then multiply by the reciprocal of the bottom fraction. And then the last thing in today's lesson is how do we do this with ones that have to be factored? So how do we take the same skill set of multiplying and dividing and factor? So I'm going to do 2 multiplying with you, and I'm going to do 2 dividing with you to finish off the day. So when you're doing these, because they are ones that haven't been factored, your job first is to do as much factoring as you can. And this could involve factoring anywhere up to 4 different things because you have 2 numerators and 2 denominators. Not always will everything factor, but you want to go through and factor as much as you can. So for the first numerator, I can take a 4 out, which leaves you with x minus 4. The first denominator is just an x, so there's nothing I can do with that. My second denominator is a FOIL factor. I need numbers that multiply to get 24 and add to get negative 11. So that's going to be negative 3 and negative 8. And then my denominator of the second fraction, I need numbers that multiply to get 12 and add to get negative 7. That's going to be x minus 3 and x minus 4. Once you have it fully factored, you are looking for any numerator factor that's identical to any denominator factor. They can be right on top of each other, or they can be kind of diagonal to each other. So for example, these x minus 3s, one on top, one on bottom will cancel. The x minus 4s, one on top, one on bottom will cancel. And that's it. Everything else is left. It will not reduce or cancel. So we still have a 4 and an x minus 8. So I'm going to keep that x minus 8 in parentheses. On the bottom, we just have an x. So that's basically you're writing your leftovers when you're totally done factoring and canceling what was still there. Next one, I can't do anything with the x plus 3 or the x plus 2, so that's going to save me some time. But I can factor the numerator of the second one. I need numbers that multiply to get negative 6 and add to get negative 1. That's going to be a negative 3 and a positive 2. And in the bottom, I need numbers that multiply to, or this is difference of squares. We're going to multiply to get negative 9, and they're going to cancel out. So we're going to get x plus 3, x minus 3. So looking at what cancels, this x plus 3 and this x plus 3 cancel. This x minus 3 and this x minus 3 cancel. And actually, I'm glad I picked this one because it's kind of something special here. The x plus 2's cancel. If everything cancels, we don't put a 0. If everything cancels, it means you were dividing something by itself, which means you are left with a 1. So that doesn't happen a lot, but when it does, you have a 1. Basically, it's something divided by itself. Finally, division. Division, you're going to start by rewriting it as multiplying by the reciprocal. So you're going to start off, first step is just to rewrite the problem. Some people like to combine steps and factor at the same time. If you want to do that, that's fine. I'm going to multiply by the reciprocal of whatever's after the division sign. And then you just turn it into a problem like what we just did. So you want to factor. My numerator will factor x plus 1, x minus 1. It's a difference of squares. My denominator is what multiplies to get negative 6 and adds to get negative 5. That's going to be a minus 6 and a positive 1. The x minus 6 can't do anything. The 5x plus 25, you can take out a GCF. You can take out a 5. And then we're going to start canceling or seeing if we can cancel anything. The x plus 1s will cancel. The x minus 6s will cancel. And that's it. So I'm left with an x minus 1 on top, and I'm left with a 5 quantity x plus 5 on the bottom. Last one. I'm going to rewrite it, but make it a multiplication problem. So I'm going to rewrite the first fraction as is and then multiply by the reciprocal of the second fraction. If you're comfortable and want to do that and the factoring all together, you can. I can't do anything with the x squared. The bottom, I need numbers that multiply to get negative 42 and add to get negative 1. That's going to be a negative 7 and a positive 6. X squared minus 36 is a difference of squares. X plus 6, x minus 6. And I can't do anything with the 5x. So x plus 6's will cancel. That's it as far as your bigger factors. Now you can cancel this x with one of these x's. And that's it. So we are left with an x and an x minus 6 on the top. And we are left with a 5 and an x minus 7 on the bottom. And just make sure when you enter in Delta Math, you have the right part on top and the right part on bottom. Sometimes the parentheses get a little messy. And that's the end of 8.4. Tomorrow we're going to continue with this and do some that are a little more complicated, but this gives you the basics for today.